right, this is the setup that's going to be for the to do the milling on this part, so that I can reach over the top of it to get these holes from the end, and there's a few notches in the ID here, and then after I get those end features that I need the steady rest for, then I could bring my my tailstock up. But I ran into an issue with this steady rest that I built. I built it for a different job, but it seems like it'll work out good for this. But this boss, you can see how close it is right here, will hit the steady rest if I move it any further this way, and it will need to rotate all the way around the C-axis all the way around to get to this bottom feature here, and as well as a hole here that I've relieved the jaws for, and then the same hole over here, and some keys in this thread that there is, and the mill around this boss I'll need to rotate around. So the issue here is it would sort of work this way, except that I wanted to hold this between centers to do a lot of that work. I don't really want to run the jaws on here all the time, and I wanted to put this plug, the lathe guys made this plug to do their work, so I can reuse it here. But when I put it in the end, when I bring my my tailstock all the way up here, I can only get about this close, because those ways collapse all the way up, and so you run out of travel when they collapse all the way, and when that happens, the tailstock, the end of the center is about this far away, and it just barely catches on this, with this clearance being as close as you saw it here. So it would be good if I could move this body forward a little bit, and I don't like this clearance being so close here like this, because if something got between here, like a shaving from the drilling or something like that, and then I rotated around through here, it could move the part in the chuck over there or damage the part. And on top of that, I've got a if you can see here, I would like to have this jaw a little bit further up on this diameter and not overhanging this thread relief here. So I've determined I can machine a recess in the front of this here, and I can go 550 thousandths deep and still maintain the same wall thickness. You see this, the jaws is off center in this base, and so that's what we're going to do in this video, to machine this. I sort of marked with a Sharpie, but I'm going to come out further. I'm going to put a 45-degree angle coming into it too. That'll just make it easier to machine, because I can't really, if I ran this thing like down that way, I could tip the B-axis so it points that direction, but I still really can't get down that low. With this machine's X-axis travel is not down far enough, and I think I might, you see that dog thing down there? I might run into a problem with it too. The bottom there hitting down on that thing. So I think what the best thing's going to be to do is to bring the B-axis and tip it at a, like say, a 45-degree angle this way, and machine this with ball nose end mills. So that's the plan. So let's take a look at the model in the spree and everything, and you'll kind of get an idea of what I'm going for here. All right, here we are in the spree TNG, and here's the model as I've imported it with the modification I modeled into it of this recess we're going to cut in the front of it. So that's the model, and take note of these big chamfers on the top of this thing, because apparently I never cut those in the real part, and that causes me a problem later on. Here's the stock definition in the software, so we can use this for the simulation part of the, well, it actually controls the tool path where it goes if you have the proper stock simulation in this software. So that's the actual model that's going to be programmed. here's the one, the finishing cut and the roughing cut as programmed. Let's go over to the simulation side of this, or the machine side of it, if you will. Now I placed this steady rest body in the location that you saw in the previous video clip, with the jaws and the chuck and the jaws and everything defined as is going to be when the part's being machined. And this is kind of important for the purpose of collision detection. I didn't bother to do anything with this, the rest of this, because it isn't necessary for this program. You may notice that this machine model isn't actually my machine. It's a newer model of the Mazak Integrex, but it's basically the same machine. So when this runs, the way covers of the y-axis here get pretty close to things. And let me hide the machine's outside sheet metal, and then we can watch this simulation. So this is the first tool, ISCAR 1-inch feed mill. It's going to rough down this part of the notch. And you can see, I don't know if you can tell, but as it gets down closer to the bottom, it gets pretty close with the y-axis sheet metal on these edges, on the chuck side and also on this corner here. So that's why it was important to properly position things for the simulation. And I also had to put extensions on the tools. These this Capto extension on the 1-inch end mill holder, and also the 1/2-inch ball mill holder, to get down here without actually hitting on these parts of the machine, especially when it's over this far. The tool's over here in the y-axis. So that's the roughing part of it. And then the tool change to the 1/2-inch ball end mill is what I'm using here. You can see it's getting pretty close right now, but when I first modeled this, or programmed it I should say, I had this angle a little bit steeper to come in here with the tools, and it actually hit this corner on the chuck. So see, that's what the benefit of the actual simulation, because this software can take into account every element of this model of the machine, not just the tool and the spindle and stuff, but the sheet metal. If you go too far this way or that way and you hit anything on this machine, and it even rotates the chuck when it's doing turning and things like that. So it's very accurate. You know, if you hit something within 1/1000th of an inch, it's going to tell you. So that's the simulation. So let's take a look at the real machining and how it happens. Here we are after making the milling the notch in the steady rest here. Now I can rotate this around. See, I've got plenty of clearance. I haven't got the jaws adjusted down on the part. I'm holding it with the tailstock. In fact, look down here. You can see these. I don't know if you can see them here. See, this is where those way covers collapse all together, and so this is as far as the tailstock could come up to the actual steady rest. You can't get any closer than this, and I'm just about at the maximum of the quill travel as far as extending it. So now let me set the camera down. You can see here I've got not much clearance now between here and here. I'll rotate the part around so I can let me move I can unclamp the steady rest. I can move it forward, let's say about like that. That also gets my jaw nice and clean on the middle of this diameter here, where I'd like it. Moved it forward off of this, it was hanging over this thread relief. I don't think that'd be a good idea. And that'll be good for the steady rest, so we'll clamp it there. And then I can back this center off here. I need to back the center all the way back. It won't let me. See if I can bring this forward a little bit more. So that's the extreme travel now. But I should have brought it closer, a little bit closer to this plug. Now it should make up a little bit sooner with a little, maybe 1/4 of an inch or so. Okay, so that's definitely in there solid now. So I'm liking that setup better. Got plenty of clearance here for rotating the part around. Like I said before, I want to do most of this milling between centers on this thing. I'm only going to have to back this off. I posted a little thing on Instagram about this, and people were saying, well, just put something in the chuck over here and move the part forward like a spacer. But if you do that, you still have the interference of the tailstock. It doesn't solve the problem with the tailstock and the steady rest, and this interference here, I should say, with the body of the steady rest. So machining that away gave me that clearance, and there'll be times when I have to back this off and move the steady rest back, and I have to get into the part with long tools. Let's say like this, I've got to drill a hole up on this boss here. I'm just holding the tool up here, so I'm going to have the spindle of the machine out here, and you can't get it in there with the steady rest there. I think some people had made some comments about this, but if I'm going to come in from the end of the part, I have to do some things up in the ID here, and then I have to also drill these holes and bore them in these two bosses very precisely. So see, I posted a post on Instagram kind of showing this and what I was planning to do, as well as I described it in the beginning of this video. But initially I have to come in here from the end, and you see I got to do work drilling in these things and boring them, and also in the ID of the part there's two notches, so I have to support that to do those operations on the steady rest. And you can't get this type of machine, you can't get the spindle down in here and be working on the end of the part with this tailstock in the way. So I'll have to back it off at least far enough so I have clearance, and then do the end work and bring the tailstock forward and put my plug in here and extend the quill, and then I'll back these jaws off on the steady rest here so they don't mar up the part any more than necessary on this diameter. Although this has stock on it, it's going to be machined down. It's got like 25 thousandths, maybe 30 thousandths of stock on here that's going to be turned off after all of this milling is done. And we left that for the purpose of being able to run the steady rest on this diameter. The finished diameter is a very close tolerance and finish, so we can't afford any kind of scratches or dents or anything like that from shavings or whatever in there. Built this steady rest for a different job, and I build them this way with the jaws. Normally a steady rest has jaws like this, that come in at 120 degree angles, but that doesn't work good for milling because you can't come down between the jaws and do any type of milling, or you could do very little maybe if you had clearance in between. But this gives you more clearance on the part to do milling operations, and I can actually reach over the top of this to drill this hole back here in this boss and also this one. So that's why I built the steady rest like this, so that the jaws are flat, but you don't have as much support going upward, which isn't usually necessary when you're milling. You're pushing downward, and it's not really a problem. It's not really, well, actually on this machine the turning tool comes straight down too, so you're pushing into the steady rest when you're turning, if you're turning with this kind of a steady rest as well. And even though the hydraulic one, the things come closed, but it won't close down to this small of diameter. And I don't want to use the rollers, because when you're milling you get shavings under those rollers, and they dent the part up. Even if you have little wipers on them, they kind of get underneath there. They find their way in there and they dent the part up. So now I have to, like I said, back the tailstock off and adjust this in here so that I have some kind of a, I can skim a little bit off the tips of these jaws on this steady rest, and then I put the part back in and clamp it. In fact, the one thing that would be a good thing to try is if I could actually get the part out of here, because I don't want to move this steady rest. Once I get it in the position I want, I don't want to move it. Let's see, I backed this front jaw all the way off like that. Let's see if I can get it out. That is something to try. It might be, yeah. So I can get the part in and out. So let me couple back onto this thing, wherever it was. There's a shot pin, kind of a hydraulic pin that goes into that dog. In fact, let me back it up and I'll show you. If you can see, I don't know if you can see that dog down there. Shine a light on it, maybe you could see it. See that? There's a dog thing right here. And the tailstock couples onto that with the hydraulic pin. So if I back this thing up to a point, and then you can put it in this mode of tailstock connect mode, and you just hit the back jog and the Z until it has some kind of magnetic proximity switches or something like that, and it can tell when it's in the right location. When it does, it stops. Like when I'm jogging it, it actually stops even if I continue to push the button, and then I can push this key on the control and it engages it and it unclamps the base of it at the same time, so then I can jog it back. I get it back out of the way far enough so I can get the spindle of the machine in here, and I want to bore these jaws to a precise diameter. All right, I got the boring head kind of adjusted to the diameter I want to cut. It's not super duper critical because I can, of course, adjust these a little bit. Let me close the doors here, and we'll start the spindle and see what we can do here. All right, put it in manual, spindle speed. Let's run about 1500 RPM, I guess. That's good. And then I want to set a feed rate here so I could jog it. Let's see what this looks like. Maybe one faster. Okay. And we'll skim those jaws off here. See if they clean up. Gotta pay attention here. I don't want to run into something with the axis of the machine. Okay. Stop the spindle here. Open the door. See what I did. Doesn't look like this bottom one cleaned up all the way. Let me see what this other one looks like. I think I'm going to tweak them out just a little bit more. Let me back this off. You can see this bottom one didn't quite clean up. So I'm going to raise it a little bit. Do the same thing. This one cleaned up, but I'm still going to do that. And I'm going to open up the boring head just a hair and run it again through there just to get a better finish. Let's come back up here, close the doors. Start. Stop. Put it in manual first. For some reason, in the milling mode, in the turning mode, this thing will keep the RPM, but I have to re-enter it for some reason. Okay. Let's see if that worked. Seemed like it cleaned up, but I'm going to index the insert on this boring head and run it through again. It's not leaving that nice of a finish. The insert might be kind of dull. I think the okay, this one, it's a new insert. I think it's exactly the same tip radius, but in reality, I'd like to bore those jaws just a hair oversized rather than undersized, because if that part fits too closely, it can dig in on the edges here. I'll round them off some, but I'd rather it almost hit in the middle more than the edges. See how this works. Back. Close the door again. Back in the manual mode. RPM, we're running 1500. Okay. Start. Feed away just to make sure we're not going the wrong way. Yeah, that finish looks a lot better. That insert was kind of dull. Okay. On the doors. That's interesting. I might feed that back through in reverse. Got a higher lead angle on the insert going backwards. It might work a little better. Manual. Start. All right. And that should be the right size. Let me jog it back out of the way. Get some calipers in here. I'm looking for that's about It's about 10 thousandths bigger than the actual diameter, which is kind of where I want it. Like I said, I want it to hit more in the middle here than on the corners here, and dig into the part. See, as the part's aluminum, I think these jaws are, I'm not sure. I think this might be bronze or beryllium copper or something like that. Thought I'd take a little clip through the window of the machine of what's happening with this part. I'm setting up the cuts. Because I have so many parts to make, I'm not filming the very first one, but I just want to show you a little taste of what's coming up. This is a 5-axis cut on this the top of this boss or ear. It's got to be trimmed down a little bit. I'm not running the coolant here because I kind of want to see what's happening. You notice that boss off to the right that pivots up there. I posted a few little shots of that on Instagram, took with my phone. So anyway, thanks for watching.